In-depth bonding, the sequel, covalent. So we've already learned about ionic, now we're going to look into covalent. So here we got covalent molecules. Remember covalent, non-metal, says it right there. And I know molecule is a small group of atoms, alright, that float around by themselves. When a nonmetal reacts with another nonmetal, both atoms have a high electronegativity. Remember they're on the top right of the periodic table. Since they both strongly attract electrons, neither element loses. Alright? They won't give up. Instead, the electrons are shared, or fought over, in a covalent bond. Covalent bonds do not cause crystals. Rather, they create small groups of atoms called molecules. Make sure you know what a molecule is. Hey, covalent. You ever think about it? Co means like together, and valent sounds like valence. So it's like they're sharing the valence electrons. Ooh. The molecules held together because the positive nucleus in each atom is attracted to the negative electrons shared between them. So it's like you and your sister fighting over an iPad, and if you both don't let go, then you're kind of stuck together. Molecules are not repeating patterns like crystals. They're a small set of atoms bonded together. Since molecules usually don't attract each other that well, covalent compounds tend to melt easily, and many are liquids and gases at room temperature. So they have weak intermolecular forces, if you remember our discussion from phases towards the beginning of the unit. Since the electrons are shared between the nonmetal atoms, electrons cannot move around, so covalent compounds typically do not conduct electricity. No moving charge. For example, fluorine is a highly electronegative atom with 7 valence electrons. When two fluorine atoms react, each fluorine atom shares one with the other so that both atoms have a full shell. Together they create a fluorine molecule, so F2, there's 2 of them. It is important to note that neither fluorine atom has a charge, since neither gained or lost an electron. The positive nucleus of each fluorine atom is attracted to the 2 electrons between them. The unshared pairs of electrons are called lone pairs. Oh, they're all by themselves. The fluorine molecule contains a total of 6 lone pairs. So let's take a look here. This is what it starts as. We have 7 valence electrons to start. They bond together. I guess these ones are the shared ones that the nuclei, each nucleus is fighting over. And these ones are the lone pairs. So sad, all alone. So that's fluorine. Let's keep reading. Another example is a water molecule, so H2O. Both hydrogen atoms have 1 valence electron, while the oxygen atom has 6 valence electrons. When they share electrons, hydrogen achieves a full shell of 2. Remember, because it only has the 1 shell. So the first shell only holds 2, so it only needs the 1 more. While oxygen achieves a full shell of 8 electrons. Since both hydrogen and oxygen atoms share electrons, the atoms are tightly bound together in a covalent bond, but the atoms do not become ions. So the atoms are bound together, but if I had another H2O here, these intermolecular forces would be weak. So that's why it's a liquid at room temperature. Okay, and look at this. So sure enough, it looks like it's sharing 1 from oxygen, 1 from hydrogen. So these ones are shared. These ones are shared. So I guess this one is alone, this one's alone, and those ones are just on the inside. They're not really valence. They're just inner electrons, I guess. Last paragraph here that we're reading together. The elements hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine form covalent bonds with themselves because they have such high electronegativities they cannot exist as single atoms. Wow, so they're so good at taking electrons that you put them, the pure atoms, and boom, they take an electron from what's closest to them, which is usually another atom of the same element. These are called diatomic, di meaning 2, atomic meaning atom, because they consist of 2 atoms each. Okay, you need to remember these. So here is an acronym, all right? It's not, I'm not endorsing anything, okay? But here's how you can remember it. Have no fear of ice cold beer. So we have hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, bromine. All of our diatomics right there, all right? Have no fear of ice cold beer. Ta-da! Okay, again, not endorsing anything. Please respect the law. Please.